Okay, a brief video on finding the area of compound shapes. It's going to be brief because you don't really have to do anything very special as long as you can find the area of some of the shapes you've already learned about. Like, for example, triangles and parallelograms. The thing to do with compound shapes are shapes that can be divided up into smaller shapes of various kinds. And in this picture here, um, we've got a shape which I would suggest, if you look at the black lines, we can divide into two things. I would suggest we can divide it into a parallelogram and a triangle by popping a line just there. You might see it some other way, but that's how I'm seeing it. And I'm seeing that if I put a line there, and above that is a parallelogram, and below it is a triangle. And I reckon I've also got the dimensions of each of those shapes so that I could then go on and find the area of each one. And so to find the area of this compound shape, I've divided it into those two shapes, find the area of each one, add them together, and that will give me the total area of the whole thing, won't it? So let's find the area of each part. Let's label them. I'm going to call a parallelogram A and a triangle B. And let's find the area of A. So I reckon we always start with the formula, boys. The formula for the area of a parallelogram is base times perpendicular height. Well done. And what's the base of this parallelogram? Well done. And the perpendicular height? It's given over here, isn't it? It's 4. So it's 6 times 4. The answer will be in meters squared, because we're talking about area, aren't we? Okay, and 6 fours are 24 meters squared. There we go. That's the area for A. And let's find the area for B now. Well, B is a triangle. What's the formula for finding the area of a triangle? Hopefully you're all saying it. It's half of the base times the perpendicular height. So you might be saying, I suppose, it's the base times the perpendicular height divided by 2. It's the same thing, isn't it? We'll do it your way. There we go. Now then, got to be a little bit cunning here, haven't we? The base, I reckon, is going to be this side here, because we've been given the height here, haven't we? This line here. How long is this line here, the perpendicular height? Well, it's 10 meters minus the bit above it, isn't it? The bit above it must be 4 meters, because it's given over on the right-hand side. So the bit below the line, the height of the triangle must be 6 meters, mustn't it? And the base here, the horizontal line here, must be equal to the line at the top of the parallelogram, because the opposite sides of the parallelogram are equal. So it must be 6 meters. So it's going to be 6 times 6 divided by 2. Let's scroll down a little bit, make a bit of space. 6 sixes are 36. 36 divided by 2 is 18. And again, we're in meters squared. And so the total area of the shape will be, if I work over to the left, will be A plus B. And that's going to be 24 plus 18 meters squared. 24 plus 18, well 24 and 10 is 34, 34 and 8 is 42, total area 42 meters squared. Just write down the formula for each shape, just make sure you find the dimensions carefully, and really nothing could be easier, could it? Let's just do one more example. Here is a shape, I've already divided it up for you because I'm lovely. It's a rectangle on top of a semicircle, that's right. Do you know how to find the area of a rectangle? Of course you do. Base times height, isn't it? Or length times breadth. Length times breadth. There we go. What's the length of this rectangle? 8 centimetres, well done. And the breadth? 3 centimetres. So it's 8 times 3 centimetres squared. 8 threes are 24 centimetres squared. Now then, let's just think about circles for a minute. How do you find the area of a circle? The area of a circle is pi r squared, isn't it? The area of a circle is pi r squared. Now we haven't got a circle here, have we? We want to find the area of half a circle. So I reckon, and so do you, that to find the area of half a circle, we're going to be finding half of pi r squared, aren't we? So let's do that. Half of pi r squared. We need to have the radius here. I haven't written any numbers along here, have I? And I haven't marked the radius here either. A bit rotten of me. However, at the top, this measurement gives me the length of the rectangle, and the opposite sides of the rectangle are equal, which means the diameter of the circle must be 8 centimetres, mustn't it? This line here must be 8 centimetres as well. And if the diameter is 8 centimetres, then what's the radius? That's right, the radius is half the diameter. And so therefore the radius in this case will be 4 centimetres. And so that's what we're going to square. So we're going to do half of pi times 4 squared. And I reckon 4 squared is 16. So we're going to do half of pi times 16 calculators out. Let me just do that quickly on my calculator that I have handy. Oops, which isn't working. Isn't that lovely? Here we go. Now that's good. Now we're working. I reckon my calculator, the answer is, for one significant figure anyway, 25.1, and we're in centimetres, aren't we? So area, centimetres squared. So there we go. That's the area of B, 25.1 centimetres squared. And that's, I repeat, to 3 significant figures. I rounded my answer on the calculator to 3 significant figures, as you should do on this by the way. So let's add those two together to get the total area of my compound shape. A had an area of 24 centimetres squared. B 25.1 centimetres squared. Add them together gives us 49.1 centimetres squared. And there we go. Haven't we done well? That's two compound shapes, the areas for each found. Start by writing the formula for each of the parts of the shape. Make sure you find the dimensions carefully. Make sure you carry out the calculations carefully. Make sure you add the numbers up carefully at the end. And you are in business. Good luck.